All right, so we started our new unit, and this unit, I told you before that solving equations is probably the singular most important thing that you need to get out of this class. Being able to work with a linear equation is a very close second. Slopes, graphing lines. Slopes, graphing lines. Writing the equations of a line, you need to be able to do that. You're going to see that a lot. It's used throughout a lot of different things in high school math and a lot of other applications, right? So, first thing we're going to work with is slope. So by the time we're done here, you should be able to calculate the slope of a line from a graph or from a couple of points. And then we're going to talk about what rate of change is, okay, and be able to figure out the rate of change in a story problem. Okay, so first things first, slope. What is slope? There are a lot of things that slope is, and there are a lot of things that slope isn't. And hopefully we can eliminate the things that slope isn't, and remember the things that slope is. So, what is slope? Well, first of all, slope tells you the steepness of a line, not how long a line is. Lines don't actually have a length. It gives us the steepness of a line. When you think about slope, from your previous experience, and I know you've seen slope before, you should be thinking of rise over run. Why? Why is it rise over run? We're going to talk about that in just a second. Slope is also a rate of change. You see the next point here. It gives you the vertical change compared to the horizontal change. So it's a rate. It's a rate of change. How fast something is increasing or how fast something is decreasing. Okay? So, vertical change, horizontal change. How does that correspond to rise over run? Because it does. Well, think about in the coordinate plane, x, y axis. Here's y, here's x, right? Vertical. Which way does a vertical line go? Where it goes up and down, right? So if we're going to go from one point on a graph to another point on a graph, then the vertical change means how far we're going to rise, how far we're going to go up in the vertical direction. It's also the same as the change in y. It's the change in the y direction. So another way to look at this is that's the change in y, and then the horizontal change is what we talk about with run. Horizontal goes this way, and so that's our run. It's also in the x direction. It follows the direction of the x-axis. So we're talking about the change in x when we're talking about the horizontal change. And so it's a ratio. We're comparing the vertical change to the horizontal change. How much does a line increase or decrease in the y direction as we increase in the x direction? Because we're always going to read left to right. And if we go left to right, if we start here and go that way, then x is increasing. So basically slope tells us how much the y value increases or decreases as x increases. It's a ratio. Okay? Now, a rate of change. A little bit more about that. Rate of change. There's two axes, an x and y axis. So there's two variables, right? Those two variables can stand for different quantities. And so a rate of change shows us the relationship between those two quantities. Okay? It compares those two quantities. All right. Some more things about slope. If you have a line that goes up and to the right, like this one is, you need to understand that the slope of that line is positive, right? It's increasing. So if I go from here to here, that means the y is increasing. It's going up as x increases. If the line goes down to the right, then that's decreasing, and so it's a negative slope. Because if I go from here to here, right, if I go from this point to this point, I have to go down, which is decreasing, and then I have to run to the right. So as x increases, y is decreasing, and that's a negative slope. Okay, what about a horizontal line? Right, a horizontal line. Well, how much is, from this point to this point, how much is y changing? Does y change at all? No, y does not change at all. There is no rise. So the change in y, which is what we think about slope as sometimes, change in y over the change in x, right? There is no change in y. So that's 0. And it doesn't matter what the change in x is, because anything divided into 0 is just 0. So a horizontal line, the slope is going to be 0. The next line is what kind of line? Yeah, it's a vertical line. Now, if I go from here to here, there is a there is a vertical change. There is a change in the y. And that's whatever it is. But the problem is there is no change in x. There is no run. That's 0. Can you divide by 0? No. And so a vertical line has an undefined slope. You cannot divide by 0. You can divide into 0, but you cannot divide by 0. Okay? All right. Let's go find some slopes. And here's the thing. A slope is supposed to tell me from one point to another point on the line how much how much vertical change we have compared to how much horizontal change we have. And we can choose any 2 points we want. We can choose that one and we can choose that one, but those become very difficult to find the values. How far do you rise versus how far do you run? We need to utilize the grid lines in a graph. To do that, we need to find where the line crosses the street corners, like walking downtown Indy. Those grid line intersections, that's what we're looking for. Where does the line cross those corners? There's 2 points where that happens. So from this point to this point, what is the vertical change? Right? We need to go down 1, 2, 3, 4, which is negative. And then the horizontal change, 1, 2, 3. So the slope becomes, wait a minute, that's not right. Don't let me do that. If we go down 4, then we're right here. So we're going to run over 1, 2. So negative 4 over 2, which reduces down to negative 2 over 1. Okay? Now you may be thinking, wait a minute, Mr. Smith, this is not what my notes look like. Well, they may not. Doesn't matter what 2 points we use. I could have chosen this point and then go all the way down here and choose this point. What's the vertical change from the first point to the second point? Well, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to go down 14. What's the horizontal change? 1, 2, 3, 4, 5, 6, 7. Look at that. It's still negative 2 over 1. Okay? So it doesn't matter which 2 points you use. The slope of the line is the slope of the line. It doesn't change because of where you are on the line. It's the same. Okay? So we just need to find 2 grid line corners, 2 grid line intersections, and use those as our points and count rise over run. Like this one. Find your 2 points, count your rise over run, and then start the video back up and see if you're right. So stop it now and then see if you're right. Okay, which 2 points did you use? I'm going to use this one and this one. And I'm purposefully using points that you probably are not using. Okay, but let's go find our slope. From this point to this point, what's my vertical change? Vertical up and down. I'm going up 1, 2, 3, 4. Up is positive. Okay, now I'm going to run 1, 2. So positive 2. So the slope is 2 over 1. You should have gotten 2 over 1 also, even though you're using 2 different points. Make sure that you do. Okay, try this one. Start the video up and I'll have the slope for you all ready for you to check your answer. Did you get 1 over 5? Okay, I hope you did, because that's what the slope should be. And it doesn't matter which 2 points you use. Okay, one more here. Give it a shot. See if you're right. Did you get negative 2 over 1? Okay? Again, the points don't have to be very far away. They can be right next to each other and it still works. Okay, now, what if you don't have a graph? What if you don't have a graph? Well, we talked about that slope is that vertical change compared to that horizontal change. Remember, vertical is in the y direction? So if I have 2 points, how would I figure out how the y values changed? Well, I'd want to find the difference in those y's. So I'd want to subtract the y's. The horizontal change, remember horizontal is in the x direction. So how would I find the x change? Well, I'd want to find the difference between the x values. Okay? And it doesn't matter which point you start with. If I went back here, instead of starting at this point and going to this point, I started at this point and went to this point. It really wouldn't matter. I would go up 2, which is positive, and left 1, left is the decrease, it's the negative direction for x. The slope would still be the same. Now, what I do need you to understand, though, is that I didn't change my mind midway, right? I didn't choose a point here and a point here, and then decide I'm going to count from here to here, 1, 2, 3, 4, and then say, well, I changed my mind. Now for the run, I'm going to go from this point to this point. We don't change our mind midway. So when we start doing this, it doesn't matter what point you start with, but we're not going to change our mind midway. We're going to make sure that our y's and our x's are subtracted in the same direction. Now here's what I mean. Every ordered pair has an x and a y. We want to make sure we label those. Now, for my change in y, for my difference in y, if I go -8 minus 6, I started with this point. That means for my denominator, I want to start with the same point and go -2 minus 10. -8 minus 6 is -14. -2 minus 10 is -12. And you simplified that into 7 over 6. And that's your slope. Okay? Try this one. Stop the video, give it a shot, and then we'll start back up. I'll walk you through it. Okay, so to find the slope, we're going to subtract the y's, subtract the x's. The y's are -3 minus 0 over 0 minus a -5. So 0 minus a -5. It's still minus a negative. You've got to put that negative in there with the 5. Because as you see, the negative and the minus sign and the negative become a positive. And so we get -3 over +5. And that's our slope. Okay? All right. Take a look at this one. Try this one and see what you get. Stop the video, start it back up, and see what happens. Okay. Subtract the y's over subtract the x's. That's our slope. What's the vertical change and what's the horizontal change? Vertical change is in the y direction, so subtract your y's. Horizontal change is in the x direction, so subtract your x's. This is -9, this is 0. Can you divide by 0? No. So this is undefined. Okay? What about this one? Give it a shot, and then see if you're right. Did you get 0? I hope you did. -2 minus a -2. The minus and negative both become positive because 2 negatives make a positive. Same thing happens down here for the 6 minus a -3. And so we get 0. Okay? 0 divided by 9 is just 0. All right, try this one. Did you get -7 over 1 or -7 or 7 over -1? Hope you did. Okay, another one to practice with here. And -1/3. The vertical change is -1. The horizontal change is 3. Okay? All right. Now, we can use the slope formula. At Center Grove High School, we use the slope formula for a lot. But let's say that I actually found the slope of the line. I had my 2 points, found the slope of the line, and then forgot the x-coordinate for one of the points. And I need to know that. I need to know where that point's located, right? Well, I can still use the slope formula and fill in what I know to help me find that x-coordinate, okay? The slope is actually -1/2. So we plug that in. The y's are 5 minus 4. Again, it doesn't matter which direction you start with as long as you keep going in the same direction. So 5 minus 4 means I'm going to go 2 minus x. Now, you have what are two ratios. The left-hand side is comparing the vertical change to the horizontal change. The right-hand side is doing the same thing, comparing the vertical change to the horizontal change. Two ratios set equal to each other is a proportion. And the way you solve a proportion is to cross multiply and solve. Now I'm going to go ahead and simplify this numerator first, and then cross multiply and solve. So 2 times 1 is 2. Distribute that -1 to here and here. -2 plus x. Then we're going to add 2, add 2. So x is 4. Okay? Same thing here. The only trick is, if your slope is undefined, what do? Well, we talked about this earlier. The reason why a slope is undefined is because you're trying to divide by 0. And we know we can't do that. So an undefined slope must have had 0 in the denominator when we tried to figure it out. Now, it doesn't matter what the numerator is. Any number divided by 0 is going to be undefined. So it doesn't. 1 divided by 0 is undefined. 700 divided by 0 is undefined. So what I choose for the numerator doesn't matter. So why don't we make this easy on ourselves and just choose 1? The math will be easier. So now my slope is 1 over 0. When I subtract the y's over, subtract the x's, then I can cross multiply and solve after I simplify. So 1 over 0 is equal to 12 over x minus 7. Now when we cross multiply, 0 times 12 is 0. 1 times x minus 7 is just x minus 7. So we add 7, add 7. So 6, sorry, so x must have been 7. Okay? All right, try setting this one up and start the video back up and check your answer. You should have gotten 33, and there's how. Make your slope 5 over 1. We like slope as a fraction. It lets us see the comparison between the vertical change and the horizontal change, so let's make it a fraction. Okay? But that's it. All right, now, rate of change. Slope as a rate of change. And we've talked about how it is. It tells us the change in y over the change in x. It's how much things are changing. Well, same idea here. The cost of a Big Mac was $1.50 in 1992. In 2005, the price was $2.75. Find the rate of change in dollars per year. In dollars per year. So how much is the price changing compared to how much the years are changing? How much time is changing, right? Well, change means find the difference. So for our price, we would need to find the difference between $2.75 and $1.50. Now, if that's how we're going to subtract, then we need to find out the time change from 2005 to 1992. Well, the price change has been $1.25. If I subtract those, you get $1.25. The time change, 2005 to 1992, is 13 years. Okay? And when you divide that out, your rate of change is 0.096. But remember, we're talking about money, so we can round this to 0.10, which means that the price has been changing 10 cents per year. Okay? All right. Next one. At 8:38 p.m., a parachutist is 3,800 feet above the ground. At 8:49 p.m., the parachutist is 1,400 feet above the ground. Find the average rate of change in feet per minute. In feet per minute. So how much did the footage change versus the time change? Right? Well, at 8:49, he was at 1,400 feet. At 8:38, it started out at 3,800 feet. So I want to subtract 1,400 minus 3,800. Where is the parachutist at the later time? That's what I want to start with first. Because that's how we would find out how much time passed, right? From 8:38 to 8:49. So from that 8:38 to 8:49 is going to be 11 minutes. And in that 11 minutes, does it make sense that the change in altitude is 2,400 feet in the negative direction? Right? Well, yeah, his altitude is getting lower the longer he falls. So he's falling, he's decreasing. His height is decreasing. So hopefully that does make sense. As a matter of fact, his rate of change in feet per minute as he's falling, he is falling, decreasing at 218.2, basically, 218.2 feet per minute. Okay? All right, try to find the rate of change for Mrs. Meyer here. Okay. So, find the average rate of change in newspapers per minute. Well, the change in the newspapers are 36 newspapers to 12. So I'm going to go 36 minus 12. And then the per minute, the change in minutes. Since I went 36 minus 12, I've got to go 60 minus 20. So I've got 24 newspapers over a span of 40 minutes. So their rate of change right, is they're delivering 0.6 newspapers per minute, right? So they're delivering 0.6 newspapers per minute, which sounds kind of weird because you can't deliver 0.6 newspapers, but it's just the average rate of change of delivering newspapers per minute. Okay? All right, that's it. Go ahead and take care of your homework. It's out in Canvas. Make sure you have that done next time.